Okay, we're going to do a little bit of factoring, a couple different methods here. The first, some people call reverse FOIL. The key thing is for now, we're only going to look at situations where the coefficient on x squared term is 1. If it's not, we need to do it some other way. I almost made the same mistake twice. What I need here is I need to have two numbers that multiply to the last term and add to the middle term, watching signs. So in this case, I need two numbers that multiply to positive 10 and add to negative 7. And so for us, negative 5 plus negative 2 will do. Negative 5 times negative 2 is positive 10. And so then our factors would just be x minus 5 times x minus 2. And that would be it. We could check it by multiplying it out again if we wanted to. Here's the same situation. Again, coefficient on the first term is 1. And so I need two numbers that multiply to negative 18 and add to negative 7. And so in this case, we have negative 9 and positive 2. Those two will both work for both cases. So our factors would be x minus 9 times x plus 2. This situation is really not that bad, but you do need to know your times tables pretty well to be able to pull all those factors out of your head. So if you don't know them, then there's lots of good places to practice them, especially lots of good apps that you can get to practice them as well. All right, here we're going to go about our factoring by a different method. We're going to use the GCF, or greatest common factor. Notice this looks like the reverse FOIL, which we just did, but a couple things different. One, the first term is not 1, although that doesn't necessarily mean anything. But also the x term is not squared, it's cubed. So what we need to do is we need to first find the greatest common factor. And the first thing we do is we look at just the numbers, so 8, 12, and 20, and what's the largest number that we can divide evenly into those three, and that answer would be 4. And then, so I'm going to erase this, write it down a little lower. And then for the variables, we have to look and we have to see how many x's do all of them have in common. So what's the largest number, or the largest number of x's? That's one way to think that all of them have in common. Or what would be the smallest power on x? So the way I like to think about it is this has 3 x's, this has 2 x's, and that has 1 x. And so therefore they all have 1 x in common. Or another way to think about it, if they were going somewhere and they had to pay in x's, and you were only going to charge them the largest amount that all 3 could pay, well, all 3 of them have at least 1 x, so that x would be the common factor. So the common factor for that would be 4x. Now, I've got to put this thing back together again. And so to do that, what I'm going to do is I'm going to divide each term by the common factor. And so 8 divided by 4 is 2, and x cubed divided by x is x squared, minus 12 divided by 4 is 3, x squared over x is x to the first, plus 20 over 4 is 5, and the 2 x's just cancel, and that would be the greatest common, that would be factoring by the greatest common factor. And last but not least, here's a special case with 2 terms. This method is known as the difference of 2 squares. The way you can tell, or the way you can look for this method is, first of all, there's only 2 terms. Later on in this class, we'll learn another method with only 2 terms, but for now, you'd be fine. Second of all, you have the minus sign in between. And then both the first and the second term are perfect squares. And what we need to do is just find their roots. So 4x squared comes from 2x times 2x. And 25 comes from 5 times 5. And so the pattern is always the same. 2x plus 5, 2x minus 5. And you notice why the middle term goes away here. the two pieces that would produce the middle term are now opposite sides. And that, again, is difference of two squares.